This is our final presentation. We have Ryan Colley as our product owner and stakeholder manager, Sandia Tovar as our scrum master and risk management, Kunal Chopra as our quality assurance, and me, Harrison Platt, working on scheduling and helping Kunal with quality assurance. So our problem is that Sandia Lab has a power analyzer that gives them data in terms of voltage and current, but it is very important for them to know the power output of this device. Currently, the power analyzer exports a CSV that can be modified, but it can be a pain to compare data through this brute force CSV method. So our problem was to create an application so that they could easily compare data, save it, and export it and visualize this data in a much more efficient, convenient way for the team. Our engineering standard is that we needed to make sure to create a product that had no environmental or health concerns, no social, political, or ethical concerns, and we needed to make a product that was simple to learn and economically feasible to use in labs company-wide.
So we broke down our problem analysis into 4 stages, the first being defining the needs. This was done really this whole process was done partnered up with our mentor at Sandia, just to make sure that we were really getting at solving the problem that they needed to be solved. So to start out, we defined the needs. The second was we laid out the constraints, which I'll get a little bit into next slide. The third thing that we did was presented ideas to our mentor. And then the fourth thing that we did was make the choice and iterate. And over on the right, you can actually see some of the models that we created early on to help guide us through the development process. So I mentioned last slide about the design constraints, and we had 4 major ones that we kind of had to work around. And the last 2 are actually where a lot of the novelty of our project came from. So the first is that we had no access to a power analyzer. That is because they're a very expensive piece of equipment, so Sandia wasn't able to send us one. And this meant that we could not use or get any of our own real data, and we couldn't use any of the data that Sandia had because they're a government contractor. They weren't allowed to send that to us. The third constraint that we had is that we needed to integrate with LabVIEW. So there aren't many examples out there of integrating Python, which is the development language we used, with LabVIEW. So we kind of had to go about that on our own. And then finally, we needed to make sure that we had a minimal tech stack. This is because this has to be used pretty easily throughout much of Sandia's labs. So we needed to make sure that it was easy to be used on all their different machines without a bunch of specifics. Moving on to the design here, we focused on flexibility to enable future integration. They actually want to take our component and our product and further down the line integrate that with a larger product that they are currently building. The second thing we needed to do was keep development focused specifically on development goals. We did this really just because of the short time frame we were working in, and we wanted to make sure that we got everything done. And then third, we designed a product to have low overhead and minimal requirements. I mentioned this in the last slide. We just need to make sure that it was easy to be uploaded to all their machines. And then over on the left, we can see kind of the flow that the program takes all the way from opening it, importing the data, manipulating it, and then exporting it. Now next is our implementation. We decided to go with the agile methodology because we felt like it would be best for dealing with some of the bugs that came up throughout the development process, and then also just taking in new stories from the mentor as they came up. So we really focused on prototyping throughout the whole process so that we were able to fail fast and receive early feedback. And that was really a big thing that we took into consideration when choosing our implementation methodology.
So our evaluation plan consisted of user acceptance testing and peer reviews. The user acceptance testing was taken care of by the people at Sandia. And then our testing evaluation, we had unit testing, integration testing, and then system testing. Since we used the agile methodology, we had a heavy emphasis on the integration testing to make sure that nothing we had implemented had broken anything else. And finally, our budget, a normal 2-month Timeline for this project would take about 26,000. However, this cost was vastly defrayed. And off to Vicente for a demo.
So what you see here when you start off the LabVIEW VI file is the interface that our program has with LabVIEW. It's very minimal. It just prompts the user to run the file, and we try to leave as little dependency on LabVIEW as possible. So all you have to do here is run it, and it'll ask you what data you want to analyze. And then after you select that data, our application opens behind the LabVIEW window. So you have to select it. You're greeted by empty graphs, and then you simply select this graph button here. And what that does is show the power for channels 1 and 2, which is what the power analyzer outputs the data in. It shows the average power, and you are able to select a specific span like this, and that span will get shown down here on the bottom. You can see at the bottom left table here, you have the average, minimum, maximum power in watts for that span that you selected. And if you move it around, make it bigger, it updates. And you're also able to see a specific time point, the statistics for that time. Same thing for channel 2 here. It's just different data, same features. You're also able to plot the minimum and maximum data if you want to really get into that specifically. You're also given the option to use Matplotlib's specific toolbar here, where you can zoom in even more and pan around and always just return to the home view. So that's when you want to use only one data set, but our customers said that they would like to be able to compare data sets so that they can maybe establish a baseline and see how their power analyzer is doing and see if anything's going wrong. So the way we did that is by having this compare option here in the menu, and it prompts you, see if you'd like to load another data set for comparison. And then once you select that data, it plots it on the graph here as well. You're able to do minimum and maximums for the data, just like you did with the original one, and move it around. Once you select the Matplotlib, you can also select a span. And you can see this table here also gets updated with the comparison data. And once you're done with that data, you can also just remove it so it doesn't clutter your view. You can also do things like import a new data set, like maybe you weren't wanting to use this data set anymore. And you can do that, and it's all the same thing. You can export this to a CSV, which we'll show in a bit, because that was one of the features that the customer would like. And they also wanted to be able to modify header mappings, which you'll see in the CSV file in a bit. But apparently sometimes some cables get plugged in incorrectly, and they would like the ability to change those labels in real time. So we implemented that for them. You're prompted here if you would like to produce a backup file because it writes to the file itself. It overwrites the data. So let's say that the data in index in column 1 was actually meant to be that for column 5. Like let's say you plugged in wire 1 into 5s and 5 into 1. You just switch those around here and click submit. The data file gets rewritten and you get the update here. You can also change the analysis start time. Let's say one of the channels didn't start collecting data until like the time point 0.2, and you just simply update that here, and that gets related to the graphs. Lastly, you can finally see the exported CSV file. So this, up until the power, is what the customer originally gave us. This is fake data, obviously, but what we added was these power statistics because they would like the ability to just have that saved instead of having to calculate it in real time as they do right now.